5.3, the last question in this section, number 4. A large bank vault has several automatic burglar alarms. The probability is 0.55 that a single alarm will detect a burglar. How many such alarms should be used to be 99% certain that a burglar trying to enter is detected by at least one alarm? Enter the smallest number. Now this problem is going to be similar to that problem number 3 we did just before this one, that last part. Let's see what we can do here. Here's what we know. We know the probability of success, a success being detecting a burglar. So that probability of success, I'll write it over here. Probability of success on a single trial is 0.55. So what we're trying to do here is we're trying to find the value of n, the number of trials, so that the probability of getting at least one success is greater than 0.99. Now to find n so that at least 1 is greater than or equal to 0.99, whenever I see that least, I think opposite. Usually works a little bit faster for me that way. And as soon as you think opposite, you need a 1 minus. All right, so 1 minus. Now, what is the opposite of at least 1? Well, at least 1 would be x would be at least 1 means none, right? X is 0. And I want this to be greater than or equal to 0.99. I mean, if I try at least 1, what would that mean? 1 or 2 or 3 or 4, I just don't know where it ends. But now I do have an end on it. The opposite of at least 1 or more, would be, the opposite is 0, so I'll think opposite, 1 minus this. And now a little bit of algebra here. I'm going to subtract 1, maybe. I'll subtract 1 from both sides, so I'll get negative p, x equals 0. That's greater than or equal to, now, 0.99 minus 1 is negative 0.01. So multiply by negative 1. And you know, when you do that, the probability that x equals 0 now is less than or equal to 0.01. Right? You have to change the direction of those inequality signs. All right, so this is what we're going to look for. We're going to go to the table, and we're going to look for just 0 under the, under the 0.55 column. We're going to look to see if we can get a 0 that's less than 0.01. As soon as we get it, then we found the proper n. So here's the table. I put the table in. It's a little bit small, maybe hard to read. But let's go to the 0.55 column right here. Now, look for, all right, here's how to read it. Here's n, here's r. So if there's 2 trials, you could have 0, 1, or 2 successes. Similarly, if there's 5 trials, you could have 0, 1, 2, 3, 4, 5 successes. And here's the probability of success on any trial. Now, we're at the probability of success of 0.55. We want to get the smallest n where we have 0 successes, and we want that to be less than 0.01. So let's go back to the table, 0.55. Now, if I am at n equal 2, the probability of 0 successes under 0.55, that's 0.203. Right? That's too big. That is not less than 0.01. So keep going down until you find something less than 0.01. Still too big. 0.01. Looks like we got it right there, right? I mean, at 5, I'm going to try something here. Okay. Maybe it'll work. I think so. All right, so now I don't know where I am. Okay, there we go. At 5, okay, at 0.55, if I go to n equals 5, I'm at 0.19. 0.19, that's too big. I want 0.1. That's a little bit too big. But if I go to 6, I'm at 0.008. That's it. That is just right below that 0.01. All right, so that's the one I'm looking for, is this right here, and that occurs over here at n equals 6. So now I'm going to go back here and say that this all works out when n is equal to 6. So back up here at the top left, enter the smallest number of alarms needed to be at least 99% certain of catching a burglar. I'm going to say 6. Now the second part says, if the bank installs 8 alarms, what is the expected number of alarms that will detect a burglar? All right, so the expected number the expected number is n times p, right? For binomial, it's n times p. This would be 8 times 0.55. Now, if it was just 0.55, there would be 4. But we're a little bit more than that, so what do we get when we do this? 8 times 0.55. Oh, let's see. I am getting 4.4. All right, that's the number I'm going to enter up here, 4.4. But let's just talk about that for a minute, because certainly if one bank does this, they can't get 4.4 alarms detecting a burglar. But suppose that there were lots and lots of banks doing this, and they all install 8 alarms. Now, some banks would get 3 alarms, some 2, some none, some 1, some 10, or some 8. On the average, we would expect 4.4 alarms to go off.